Today we will be discussing arithmetic progression. An arithmetic progression is a sequence of numbers such that the difference between two successive numbers numbers is a constant. Okay, so what do we mean by that? Let's take the example of a sequence of numbers like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's an arithmetic progression says that the difference between two successive numbers in the sequence is the same or a constant. So if you look at like the two successive numbers, the first and the second number, the difference between those is 2 minus 1, in this case is 1. Similarly, if you look at like the second and the third numbers, the difference between those two numbers is 1 as well. Similarly, between 3 and 4, 1, and between 4 and 5, 1 as well. 5 and 6, 1, so on and so forth. So this is an arithmetic progression. Okay, let's take another example of a sequence of odd numbers: 7, 9, 11, 13, 15, 17, 19. In this case, the difference between the first and the second number or the successive numbers is 2. Similarly, second and the third number is 2 again, 2, 2, so on and so forth. So in this case, the difference between two successive numbers is 2 and is a constant. So this is an arithmetic progression as well, a sequence of odd numbers between 1 and 20. You're given the sequence of numbers. Okay, now you're supposed to find what is the sum of these numbers. Plus 10. So what is the value of this? Now, the logical way when you look at this is to the most obvious way is to just sum these numbers up one by one. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, so on and so forth. But as you can see, it gets pretty tedious because this is only a sequence of 10 numbers. But if you have like a sequence of 20 numbers or maybe a 30 numbers, it gets pretty tedious to calculate the sum. So there must be an easier way to do it. And let's talk about that. Let's consider the first number in the sequence and the last number in the sequence. So if you add those two numbers up, you get a sum of 11. Now let's consider the second number and the second last number. So that's 2 plus 9, and that is 11 as well. Similarly, let's consider 3 and 8, which is the third number in the sequence and the third to last number in the sequence. 3 plus 8, that is 11 as well. Similarly, 4 plus 7, 11. And 5 plus 6, finally 5 plus 6, that is 11 as well. As you can see, each of these pairs of numbers gives a sum of 11. And there are 5 pairs like this. And the total numbers in the sequence, let's call that as n, is 10. So there are 10 numbers in the sequence, and you get 5 pairs, which is n divided by 2 pairs. N divided by 2 pairs. So you have 5 pairs of numbers equal to 5, and each of them is summed to 1. So the sum of these numbers is 5 number pairs into 11, which is 55. So we can say that the sum of this sequence is 55, which is the number of pairs in the sequence multiplied by 11. Okay. Now let's take another example of the odd numbers that we talked about earlier. So you're given the sequence of odd numbers: 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Okay, supposed to find the sum of this sequence. Okay, 1 plus 3 plus 5. Okay, what is the sum of this? So let's use the same methodology that we used earlier. So let's look at the first number and last number. So it's 1 plus 19 is equal to 20. Then similarly 3 plus 17 is equal to 20. 3 is the second number and 17 is the second to last number. Then 5 plus 15, that's the third pair, which is 5 is the third number and 15 is the third to last number. And then fourth pair is 7 plus 13, which is 20 again. And finally 9 plus 11 is 20 again. So again, you have 5 pairs of numbers and each sums up to 20. So you have 5 pairs. And the total numbers in the sequence n is 10, and you have 5 pairs. So the number of pairs is equal to n divided by 2 is 5. So we can say that sum of this sequence is 5 into 20 is equal to 100. Okay. Now this gives an idea of how you sum up the sequence of numbers. Now, if you want to generalize this into a bigger formula so that you can calculate the sum of any sequence of numbers irrespective of how many numbers are in the sequence, we can say that if you are given n numbers in the sequence, okay, and the number of pairs will be n divided by 2. And as in the previous example, you sum up the last number and the first number, and that will give you the sum of the sequence. So L is the last number in the sequence and F is the first number in the sequence, and n divided by 2 is the number of pairs in this in the sequence. So we can say that in general, sum of an arithmetic progression is equal to number of pairs in the sequence into sum of the first number and the last number. Okay, so let's apply this formula to one example just to demonstrate the idea. So you're given the sequence of numbers 1, 2, 3, 4, 5, 6, 7, so on, 93, 94, 95, 96, 97, 98, 99, okay, and 100. Okay, so there are 100 numbers in the sequence. So n is 100. So the number of pairs is equal to n divided by 2 is 50. And the first number in the sequence f is 1 and the last number l is 100. So we can say, based on the formula, n divided by 2 into l plus f is equal to 50 into 1 plus 100, which is 5050. That's the sum of the numbers in the sequence. Okay. Hopefully you got the idea of how to add a sequence of numbers which are in arithmetic progression from these examples.